Thank you, Dr. Navansu. I'm audible, but screen is not moving, na? Not moving my side. Yeah, I have stopped. Dear colleagues, till now we were in our. This is last. This is last. Yeah. Till now we were in the arena of agrometeorology, but still we don't have connectivity with our own domains like agronomy, soil science, plant pathology, entomology, nematology, seed science, vegetable science, horticulture, and whatever left in agriculture. So, for your science or your domain to be visible and authentic, you must have sport of meteorology. Means your every experiment or science must have backing of meteorological data. And after getting realistic data, you must have is statistical analysis. If you have both these arms with you, then your domain or your expertise or your research paper or your big book or your CV will be visible globally, and you will be in demand in any sort of collaboration. So to be along with the system, we have to have first data collection, data observation. Next, sir. Next, yes, here you have to observe weather parameters and what are the parameters. We will study, we will look hurriedly in our presentation. Then various instruments and then how data is being collected globally and at your place. Then evapotranspiration estimation, then soil moisture measurement, because these two parameters are the ultimate for agriculture system to perform. Then we have crop weather relations. Yes, we have to be very keen observer how any weather parameter influence our crop growth or its other subsidiaries. Then we have weather forecast interpretation. We got weather forecast from National Hydrological Meteorological Agency of respective countries. But how to interpret in farmers' language, and then to prepare an agromet advisory services, and then ultimately how it is important, because every science or our research work has to go to the welfare of masses, and we are in the middle of this system, so we are more responsible. Next, here when you start an experiment or write a paper, your location, geolocation, geo coordinates, where are you, your altitude, longitude, latitude are must to be visible on this small or big planet. So first you have to have your altitude, like our all mobiles or GPS system have all these three facilities. So when you plan experiment in your place, you must know what is latitude and what are the longitudes and what is altitude of that area, so that anyone who is reading your research or experiment or the results, he may see through his own mind, yes, this place is there and this, such type of situation where happens. So geo coordinates of your study domain is must. Next, then if you are in a university or in some academic institute or in some R&D institute like national or uh, provincial importance, you must have the observatory, meteorological observatory. The purpose of agrometeorology observatory depends the need of the data, whether you are in the airport or you are in the urban city or you are in hills or you are in the plains. So the your observatory is accordingly. Here we have agrometeorological class A observatory that has dimension of 55 meter from north to south and 36 meter east to west in northern hemisphere. The location of the observatory or from the data you are taking, that has to be representative of your farm. Means it should not be in the corner or in near some big pond or near some building. It must represent like your research farm, so that every data coming out of that observatory represent the whole farm. Next, then to start with, the first and very important uh, instrument is or the parameter measurement is rainfall. Here you can see black one is the ordinary rain gas and another is self-recording rain gas. It is taken in 24 hours reading. When rains come in this black one or silver one, then next day observer goes to the observatory at stipulated time, local mean time as per the standard device for that particular station. And then if any amount of water is there, then he will measure with this measuring cylinder, and the total amount of rainfall is there in this black one. In case of automatic rain gauge, you can measure the timing of rain started, the timing of rain stopped, and in between how much it peaks started from amount of rain during. So if you have both, then you can tell them yes, at that particular time it started and stopped. But in case of ordinary, you simply have only total amount of rainfall uh, during last 24 hour. And in this automatic, there is a chart for 24 hour, and this ink or a pen with ink will mark that this is the time where the rain started, and you can plan your or accordingly your comments or your operation or your remarks may be there. Next, then we have very important air temperature. Under air temperature, we have Stevenson screen to house all these four thermometer. Right. Yeah. Yes, sir. When like we are in observatory where we have Stevenson screen that the outside environment and inner environment is the same, and the representative observation will be there. We have four thermometer. For one is for maximum temperature, another is for minimum temperature, another is dry wet bulb temperature, another is last one is wet bulb. Maximum is around 2 and 2:30 when sun the day is clear, and minimum temperature is just before sunrise. So two type of you know, alcohol and mercury are there in respective these. And if the observation of dry and wet bulb are very near to each other, means we have full of humidity, and in case of fog or rainy, it's almost identical where RS is around 100%. Next. So these data is very important for disease or insect pest infestation or water evapotranspiration, uh, and this is automatic measurement of these temperature and humidity through thermograph and hair hygrograph, because human hair is kept in this instrument which is very sensitive to soil, so air moisture, and it helps at what time and this the maximum temperature was there and at what time the humidity was there. But in maximum and minimum you have only one value of last 24 hour. Yes, that this temperature during 24 hour was this much or that much. Next. And this is sunshine recorder. Yes, what, because it is very important to grow a crop when you know the photosynthetic hours or the bright sunshine hour in your location. So you can plan such type of crops, or you can say this is agroclimatic characterization of your region. And on the basis of season, you have different type of cards. When sun rises and it start have some brightness, then the car goes on burning, and observer come on the next day before sunrise, and they will calculate how much the total amount of bright sunshine. This is also important for photosynthetic activity measurement, or to calculate the amount of net radiation or long wave radiation. All radiation studies we use this through various empirical formulas. Next. And in we have soil temperature measurement also at different depth, which is very important for 1 month after sowing, when your seed germination, when the seedling is established, at what temperature, at what depth the temperature helps in germination. And also the other grass temperature in winter season helps, that this is likelihood of any frost or some minimum temperature hovering around, so that you can plan your advisory accordingly for the growers in the vicinity. Next. And here you have anemometer where we can know the wind speed or last 24 hour. The reading shows that was the reading last at 8:30 yesterday, and today at 8:30 it is this much, and divided by 24, then you can know that this was the wind speed. This is also very important in case when you have some evapotranspiration study or some disease sports in different in the system takes place. Next. And here these open pen euporimeter, US open pen, where we know the loss of water on daily basis. This very stilling well is there, and this tank is covered by a wireless on put on a wooden structure, so that we can avoid the heat of the direct heat of the earth, and to avoid any loss of water due to birds or some stray dogs. We have covered this, and the loss of water, this help in evaporation, and with the use of our crop coefficient, we know the evapotranspiration of your crop, the atmospheric demand of the water demand of the atmosphere, your crop demand, and the basis of you can plan irrigation, or this also being used for advisory services or planning your digitization of online sometime irrigation or fumigation, etc. It's very important studies. IMD has special installation of these uh, instrumentation in agriculture domains. Next. Here we have dew measurement, because dew is also very important for both in dry regions and in humid region also, where in humid we know at what level of crop height the dew is there, and if more dew is there or less dew is there, so that with the help of entomologists we can plan, yes, this is the likelihood of any particular insect or a disease to come, and we can plan accordingly. And in dry regions, it may help some substitute or back up some moisture to a plant, at least for its survival. So these studies are also very important. We have manual this do divani do gas, and we have attached with the automatic weather station on another side. Next, here this gravimetric lysimeter. This is special, just like a weighing big weighing machine you might have seen on roadside. Likewise, here in crop field, this lysimeter is put, and the surrounding crop which is in the field is also shown in the, and the daily on the daily basis the loss of weight in the tank due to loss of water is measured using this weighing balance, and we can have direct evapotranspiration. IMD has also have single stations using this study also in many SAUs. Next. Then we have automatic weather station. Yes, very, very important, and lot of data set it may generate. Under standard observatory, you have limited data in 24-hour or might be twice a day, morning, evening. But here you can program your device according to data, every minute, every 2 minutes, every 5 minutes, every 1 hour or so, a lot of parameter, different height, but data volume is too high that then later on you have to analyze and to come to any conclusion. But here the this is very costly, and it needs a lot of maintenance and open, and its life is generally 5 or 6 a year, depends upon. But for standard agrometric data, you have to keep on your study going on. But here you have to have more investment in times to come, recurring investment. Next. Then we have some microclimatic study for higher classes. We have energy balance studies with our students during the noon hours, and the various multi-channel instruments are there to know whether the long wave radiation, net radiation, or the radiation used in heating the air or heating the soils. And even in nocturnal radiation, we have studied during one of the project of ICR in this dark place. And it's also very important to have all type of data to strengthen your research, to help other breeders or other domain expert to demand according to the happening of environmental parameters. Next. Then we have this neutron probe where we study the soil moisture. So radioactive element is there inside this, and these pipe you might see this pipe, and we put this instrument through this wire and take the readings that how much amount of moisture is there at different depths. It's very costly but very dangerous also. So being a radioactive material inside, we have to have extra careful to follow all protocols of this. So this is a very advanced instrument for soil moisture measurement at different depths. Next. Yes, here in the crop canopy we have psychrometer where we have dry and wet bulb thermometer, and here we have some chlorophyll meter, and this is for we to run the instrument using solar panels, and here we have some humidity or moisture based sensors. So these are very important in a crop canopy to study the microclimate within the crop canopy, so that at what level of height, whether the old leaves performing in which style, or the fully grown up leaves or the young leaf. So to compare all these to crop geometry and crop canopy, these are very important for diurnal study in a crop environment. Next. Yes, these or more important parameters are there, and the pressure bump instruments are there to know the water potential inside the crop, and the photosynthetic activity, these tomato openings. These are the very sophisticated instrumentation which are the part of advance in agrometeorology at master's or doctorate level, and these are being calibrated regularly with the help of the engineers, and we have to maintain this with extra care so that that can perform better. So these instruments for photosynthesis or stomatal potential or water potential, these are used. Next. Yes, on continuation of some other refined studies for radiation purpose, we have photometer, we have porometer to have in different crops like gram. We are using this for in a, to attain the objective of a particular project. And within those projects, we have to have our master students to complete these studies. Next. Here infrared thermometer, with the help of this we can measure the temperature of the crop with a click of button, and we can know yes crop is under stress or under normal condition. If under stress, then we have to have irrigation or whatever planning, and then we have a GPS system, laser leveling system to have to save water within your field to have good level like this, using this laser leveler with the help of GPS, and we plan. And in the other side we have some dew shelters where we can study yes in a particular region how much dew is coming, as the climatology of dew is studied, and in open and in indoors how the different disease are happening, and control measure we can advise the pathologist or extension specialist to advise on these issues when your crop is under these conditions. Next. It's also agronomical practice. We use generally leaf area measurement and various type of leaf area measurement instrument, direct or like canopy analyzer, or we have to have physical leaf area after getting it from the field, bring to the laboratory, and then we can measure what is your leaf area index in a particular small unit of area, and whether it's performing well or is underperforming or below performing, because this realistic data will help in uh, your model preparation or validation, etc., so that it is very important to have realistic data. Next. Yes, it's a continuation of leaf canopy analyzer where we can see yes, this is the this much of your canopy in this particular area, and this very advanced instrument is very costly too. Next. Yes, this we have. If anything, we want to have in north hemisphere to make a building or some project, we have to have it in the north side because sun is coming from east to south to west, and then to avoid shadows, then we have to have any building or big tree if there. Otherwise, they are to be away from to check the hindrance or shadow of the any building or tree. So our observatory have this building on the north of its uh, location. Next. Yes, this, we can see our observatory from here. How different we if you have a team of good worker, then you will be approached by the various agencies of national, like in India, and IMD is there, IITM is there, ISRO is there, SEC people are there, lot of people, IITs are coming, which have very big and costly instrumentation, and they will collaborate you to have realistic data. Then you have to have such type of installation. That's why I put this slide here. Next. Here we have a collaborative study of WIFAX, winter fog experiment in collaboration with IITM. Generally, the basis of this project was to predict the foggy condition or visibility in Indira Gandhi Airport in New Delhi, or in the region where a lot of economic activities are halted due to this visibility in January or December. And that's why they plan a project within the 200-kilometer vicinity of New Delhi all around, and they install some ADICO variants, fog visibility analyzer, and they collaborated with us so that we can have the feedback or realistic data to forecast further the visibility in the winter, so that the flights or to take advantage of this. Then I got some student who work on masters in on this foggy water studies, or so that, because our objective was to train our student on this aspect also. The main objective of project was to predict the visibility on the IG airport and its surroundings. Next. Yes, these are the collection from the fog samples. You can say this air sample so black in 24 hours. Uh, Being a ruralite institute, or still we have full of polluted air. So it depends from which direction the wind is coming, and where any big industry is there, or what sort of thing. So we know the real picture. Yes, we are doing in a very situation. What will be the situation of the people who are living in big metros, where full of these AQI issue is always there. So the chemistry of these samples, water samples, and other these PM or some other chemicals, they study by IITM Pune, and they publish these in a very big journals of reputed journals. But I recruited 2 or 3 my students who did their master's and doctorate on these aspects also, one of the as objective. Next. Yes, then we have another experiment with IIT Kharagpur, when one guy came to us to have some laser beam, and to know this, also to have another way of monitoring visibility in the region in parallel to the Wi-Fi. But for this, we have to have very dedicated researcher along with them, because in SAUs or in national institutes, there is a difference of working. We have to have everything through our top brass permission, but in national institute, they have some liberty. The actual researcher can plan and take permission with no time. So, but we have to have compromise and to have such type of study, collaborative study, so that we can have a data network for the nation or for the region. Next. Yes, these are the samples from fog. When we measured 2.5 pm uh, uh, AQI, or rather particulate matter, then on those foggy days, we take samples of this foggy water, and sometimes we have very black water, sometimes some another, and that is being duly standardized and studied, and in the IITM laboratories in Delhi and Pune. And in this way, we concluded this project of last year, and with some operational portal also in the winter. Next. Yes, because it needs 24-hour rather electricity. It's a big problem in SAUs where during the morning hour when the fog is there, then you have to have your own house building to run it on the top of your house and to have electricity so that your results or your science continue irrespective of your non-availability or power cut in the main campus. So this is one of the picture on my residence I used to on the top of the floor. Yes, we have to have data first. Next, then again sample as various days at the top of my house, and that was also shown in the previous slides. Next. Yes, that is the portal. It's linked with IMD also. It's available on the IITM portal, air quality management, and then you can measure yes what will be the visibility in next 1 hour, next 2 hour, next 3 hours based on the data available from Hisar, from Jaipur, from Agra, from Chandigarh, and within the 200-kilometer vicinity of IG Airport. And then on the basis of this, they have their operational schedules accordingly. Next. Yes, then we have being very near to Delhi and we have very collaborative studies with IMD also, with some foreigner also, and we used to have our field experiments. Next. Yes, we have Director General Dr. Tyagi, Air Marshal team from IITM, some farmers, and to know how it is relevant to their farming. So we are to be always there to have the relevance of agrometeorological data for any activity. Next. Yes, in 2005 I make a first of departmental portal where everything was placed. That was not dynamical, but we have all type of information required in 2005, and later on it became a everyone has a portal right now. So it is very important to have your everything visible through every mean you have. Next. Yes, then after getting this standard observatory, I had a project by Ministry of Education with the Swiss government that was with Zurich, which is almost sixth in the world in ranking, where Albert Einstein worked, and they produced 21 Nobel laureate, and I had a chance to have a project with my colleague there. So we will have some few glimpse of data observation or the outreach activities. Next. Yes, during those visits, we were there in one of the very beautiful, peculiar building. Dr. Navansu will tell what will be the specificity of this WMO headquarter. It very rarely use electricity. It's naturally built in a such a way that it remains cool and full of light. So I had a chance to visit, and Dr. Navansu is a part and parcel of this scientific activity running from this WMO. Next. Then Swiss climate likely to happen, the current scenario and the previous map, they are everyone is under stress of climate changes. Alps are just melting, and then they have very concern about their agriculture. The ETS, the institute who do some study on this, they are very concerned about agriculture. Like we are concerned about this year monsoon forecasting and the likely consequences. Next. Yes, the department in ETS Zurich, they have everything displayed on the walls, and they are very keen to tell what is they are doing and how it is being done, and what will its advantage or disadvantage, how it will be used. So this is one of internal visit when I was there in Zurich. Next. And these are two students, girl students in our project. The project was 4 years during Corona also. And these girl students, they are doing PhD. And they both have their experiment at least some 50 kilometers away from their institute. And they have to maintain everything uh, there, whether any electricity issue, or some mechanical damage, or some data issue, the girls are perfect. They know everything. But here in India or in our region, we have different worker. For electricity, we have to ask someone else. For some mechanical laws or to save our experiment, we have to ask someone. And for observation, we have to believe on observer. But there, the difference is that is a complete set of see or the researcher. They are perfect engineer and researcher to work their own work. Even they have to drive safely to go to their field. So it was very really wonder for us. Yes, they are managing. But here in India or in the region, you can't expect this much from our scholars due to various reasons. Next. Yes, similar. When we visited their fields, and they were very keen to tell what is they have done and what is their objective, and everything perfectly. So we have to learn a lot. Even being in faculty, we have to very in learning mode. Next. Yes, it was my professor, host professor Werner is a well-known figure on greenhouse gases emission, and he want to uh, prepare a instrument that is very economical, because to measure the greenhouse gases from your field, the instrument cost is lakhs of rupees. But he was trying to measure a small amount who can be in 25,000 or below. And he was almost successful, but unfortunately, he was having a cancer, and last year he just left this planet. Next. Yes, if Dr. Ravansu will be agree with me, this is the first supercomputer India bought in 1990, Cray XMP-14, which was installed in satellite building. This was taken from USA at the time of President Ronald Reagan and Prime Minister Rajiv Gandhi, and that is in the museum written put there in the Zurich. But nowadays in India is a superpower in computing system. But on those days when NCMRWF was started from an IMD, that was purchased, and it was maintained by the SPG or the forces from uh, US also to keep the check whether India is using this only for meteorology purpose, and they are not allowed for other purpose like military or some other maybe. This is a sample of that supercomputer in 90s. Next. Yes, yes, you are right, sir. Next. Yes, when we visited farmer's field, how a farmer maintain his farm and how he produce own eatables and how he sells, and they do their completely involved in their system. But in India, it is really not possible. We have syndicates, we have some in between agencies, and then lot of hue and cries. So farmer has to depends on so many things for advisory, for monsoon, for inputs, for purchase, and so many things. But there, a farmer is dependent, and if a farmer want to shift his profession, he is being compensated, yes, and he's being trained. Yes, I am leaving this farming, and why I want to go in this. Yes, okay, you will be compensated for this, and you will be trained for next. So it's happen in some countries, including Switzerland. Next, yes, some evapotranspirational study, lot of lysimeter are planted, installed in a field, and a lot of crops are grown, and they are being, it's a long-term experiment in one of their research farm. Next. This was the instrument Dr. Werner was trying to build, and a prototype was managed, and we have some studies on different crop, a particular crop, how much greenhouse gases it emits. So we had some observations during our this visits. Next. Yeah, our students, PhD scholars, and when we have these instrument in our field, and when we were together in one of our department, so that everyone knows, yes, if anyone want to have, data is freely available, meteorology, your advanced meteorological data. You have your guts to make it relevant with the input of use data and analysis with the statistics, and then your science or your domain will be visible. Next. Yes, during some observation with this instrument, we have different agronomic conditions, like we have onion, moist soil, onion plus standing water, and dry. Under these conditions, how much CO2 is released, how much methane is released, how much water vapors are released. So they are trying to have some prototype of measurement. So the monopoly of big companies who are measuring through costly instrument can be taken care, and uh, that project is still going on after the unfortunate demise of the professor, and still continuing with some other guys there in the Switzerland. Next. Yes, then they have, like ours, we have presentations, seminars, what we results, and every master's or doctorate students has to be grilled like anything, and they involve everyone in their making all these results visible to the world. Next. Yes, when they used to make even picnic in the hillocks, in the farms, or in Amazons, big machineries, and they are being taken away some 50 or 100 kilometer away to know the agriculture, the experiments, the different growing season, and but luckily we have very dense SAU system or KVKs or observatories. Even we have some qualitative issues, ad hocism, but they have their well placed calculation and measurement, and then final result outcome. Next. Yes, then they have on the weekends, they are free to move here and there, even in department. When the head of the department got some highest citation of their paper, her paper, there was a party and a toasting was there, and they enjoy small achievements also. Next. Yes, with this, I conclude my this interaction. You can say not, but the main objective is you must have data. You can have data. You must know from where you are getting data, whether it is well authentic. If you want meteorological data, then you must know, yes, from where I need the data. the conditions should be similar to me, so that it may be authentic, it may be realistic, and it may conclude in a faithful way. And that's why when you have data, you have your own expertise in plant pathology or entomology or soil science. If you have data of meteorology and you have statistical intelligence around you, then your research will be visible and acceptable by one and all on this planet. Next. Yeah, I had some collaborative projects before my supervision in 5, 6 countries from Brazil, US, Switzerland, Australia, and Italy, Germany, and so on. If nowadays, if you have anything to show, there are so many platforms, so you will not be hidden. So just like Dr. Navanso is well known and is trying to push you on the regional domain at least portal, and then if we have something to start, then you will be in loop, and in this way you will be part of family for the region, for the continent, or on the global platform. So it is not merely a training to know something, but it is to make you visible on the platform you wish to. Next. Yes, that was all about my presentation. Thanks for your patience and the time given by Dr. Navanso. Thank you, sir. Yes, sir. Yes, sir. Yeah. Yeah. Right now, sir, it's very difficult because very few, only one or two guys are there, and they are busy in other than science activities, rather in students' activity. They have very little time for, and you are rightly said nowadays, due to depleting or casual manpower, we are unable to do this study. In early 90s or 80s, we were spending full days on our farm. But nowadays, we have months together to visit. So you are rightly observing that situation has changed, or some data is available online or through various modes of remote, and so without yeah, yeah, they can be, yes, rightly said, sir. We can explore the maker of this company. We are on the still on their mailing list to have some sort of agrometeorological instrumentation company. We can present, we can invite them. This may be their business venture to showbiz their. Yeah, yeah. Yeah, it is possible, sir. That can be approached. Yes, yes. Yeah, yeah. That is more important. Yes. Yeah, that can be done.